Myself, Manoj pursuing final year biotechnology at KS Rangasamy College of Technology. My final year project is entitled as Production of Biodegradable Bags from Millet Bran Husk under the guidance of Dr. J. Philip Robinson, Professor and Head, Department of Biotechnology, KS Rangasamy College of Technology. We all know that plastic bags start out as fossil fuels and end up as deadly waste in landfills and the ocean. Birds often mistake shredded plastic bags for food, filling their stomachs with toxic debris. For hungry sea turtle, it's nearly impossible to distinguish between jellyfish and floating plastic shopping bags. In India, generation of plastics are increased from about 2.6 million ton in 2003 to about 3.6 million ton in 2007, according to MOEF 2007 report. Only 8% of the total plastic waste generated in 2011 was recovered for recycling. This is according to EPA 2011. We all know that millet husk is came out as agro waste. Millet is a staple food for a large population in southern part of India and semi-arid part of tropics. In the last few decades, natural polymers have assumed a reasonable attention because of their better properties and environmental issues. Natural polymers have some advantages over the conventional materials in terms of renewability, availability, low density, and biodegradability. Cellulose fibers and their derivatives are one of the most abundant renewable polymers resources available. Cellulose is a high molecular weight linear polymer. We all know that unlike reusable fabric bags, plastic bags can take many lifetime to biodegrade. Over that time, their lightweight allows them to carry long distance, causing environmental havoc along the way. Production and incineration of plastic will contribute greenhouse gases in the equivalent of 850 million tons of carbon dioxide to the atmosphere. Plastic pollution on land poses a threat to the plant and animals, including humans who are based on those lands. Plastic waste entering the seas is increasing each year, with much of the plastic entering the seas is in particles smaller than 5 millimeter. As of 2016, it was estimated that there was approximately 150 million tons of plastic pollution in the world's ocean. My complete project will focus on the Sustainable Development Goal which is provided by the United Nations. The complete project will mainly focuses on Sustainable Development Goal number 12, responsible consumption and production, goal number 15, life on land, goal number 14, life under water. At first, the collected millet are grind to obtain millet husk. The millet husk is treated under alkalization and acidic treatment to produce cellulose. The extracted cellulose then undergo characterization process. In this characterization process, I took Fourier transform infrared peaks to match with other commercially available cellulose. In this mainly the peak values such as 3730.59, 3426.62, 2821.12, 1638.56 and 644.12. These absorption bonds are similar to that of the commercially viable cellulose. So through this FTR result, we can conclude that the obtained cellulose is also a cellulose. Then the obtained cellulose is then converted to carboxyl methyl cellulose. When compared with cellulose and carboxyl methyl cellulose, CMC has better retention capacity and CMC is less poisonous when compared to cellulose. So we convert cellulose to CMC, and this cellulose methyl carboxyl methyl cellulose will undergo for FTAR. FTAR Under FTAR, the absorption values such as 3321.56, 2951.36, 1436.63, 1315.25, 1086.78 are more equivalent to commercially available CMC. After CMC, the obtained carboxyl methyl cellulose is combined with glycerol to obtain millet husk bioplastic film, which is shortly named as MHBP. The MHBP is undergone FTIR pits. Most of the absorptions are similar to that of the other viable other commercially available bioplastic film, and mainly the absorption values such as 3366.53, 2791.88, 1590.24, 1436.30, 1020.68, 941.78, 896.35, 709.12, shows a very positive result that bioplastic film obtained from millet husk is more similar to that of the bioplastic film obtained from various sources and other bioplastic films. The same images also show positive images that these can retain water capacity, and along with that the surfaces are smooth and there is no unwanted peaks over there. And the abdomen bioplastic film is undergone for mechanical property. The tensile strength and elongation at breaks are noted, and it shows the positive result that if a tensile strength of the obtained bioplastic film is increased, it definitely will be used as commercial product, and it will be used in different industries such as food packaging industries and other cosmetic packaging industries. Then the solubility test is undergone to show that how the millet husk shows a positive result against the solubility. Uh, it shows a positive result against methanol and ethanol. When compared with benzene and H2SO4, under H2SO4 it completely solubilized, and in benzene it partially solubilized, and in methanol and ethanol it is insoluble. So it can be used in it shows that it can be used for chemical industries for in limited purposes. Along with that, swelling test is also carried out. In water, it swelled and it absorbed more number of water and it swelled, and it shows some positive result over chloroform and methanol. Degradability test is taken to show that at amount of period it takes to degrade completely, and it also shows a positive result that plastic obtained from millet husk can be used in different industries, and it will be degraded when the climate changes occurs. If we are supposed to use bioplastic as our daily product, then it saves many non-renewable sources of energy. It reduces carbon emission. The consumption. It also reduces the consumption of energy. It also will be a eco-friendly solution to many problems which exist in our nation. So references. Conclusion. This project completely focuses on circular economy and sustainable development goals. Millet waste can be used as raw material, and we can build entrepreneurship to start a new company in every street to reduce water pollution in river basins. We can provide enormous work opportunities to rural women, which leads to women empowerment and improve their livelihood.